As the lock nut is tightened, it drives the bearing up the tapered sleeve. This causes the sleeve to tighten down on the shaft. The last type of mounting we'll look at is mounting a bearing without an inner ring. In this type of mounting, the outer ring and rolling elements slip over a specially hardened shaft. The rolling elements are in direct contact with the shaft, which acts as the inner ring of the bearing. This kind of mounting is often used when there is not much space around the shaft. Bearings are usually enclosed in housings. The housing is the part that surrounds a bearing and holds it in place. In order to support the bearing, the housing must be able to handle the types of load that the bearing is subjected to. The load is usually transferred from the shaft to the bearing to the housing. Most housings contain lubricant for the bearing, and they also prevent dirt and other contaminants from getting into the bearing. Bearing housings are divided into two types: pillow block housings and built-in housings. Pillow block housings are located outside the machine casing and are separate from it. In some cases, the pillow block housing holds the end of the shaft. In others, the shaft passes through the housing. Pillow block housings can be either solid or split, and they come apart in different ways. Some solid pillow block housings have a removable cover. Once the cover is removed, the housing can be moved out of the way and the bearing can be taken off the shaft. With a split pillow block housing, the top of the housing can be taken off. The shaft can then be lifted out so that the bearing can be removed. A built-in housing is actually part of the machine casing. In many cases, the shaft and the bearing are completely contained within the machine. To reach them, the casing must be taken apart. Built-in housings may also be solid or split. The solid types of built-in housings usually have removable end caps. Removing the end caps allows the bearing and the shaft to be taken out of the machine so that the bearing can be worked on. With a split-type built-in housing, there is a joint in the machine's casing that must be taken apart to get to the bearing. This allows the shaft and the bearing to be lifted out so that the bearing can be worked on. Bearing housings can be built either to allow a small amount of axial movement or to completely prevent axial movement. A housing that allows a small amount of axial movement is said to have a floating bearing. A housing that prevents all axial movement is said to have a fixed bearing. Both types of housings may be in the same machine. A shaft usually has several bearings spaced along its length. As a rule, only one of these is a fixed bearing. The others are usually floating bearings. All bearings need to be lubricated in order to reduce the amount of friction and wear that occurs during normal operation. Rolling contact bearings are usually lubricated with either oil or grease, and that's what we'll be focusing on during this part of the lesson. As we do, keep in mind that some bearings are permanently sealed and do not need additional lubrication. Your plant's maintenance procedures should specify which bearings require additional lubrication. We'll begin with lubrication methods that use oil. Generally, oil is used to lubricate bearings installed in machines that operate at a high speed under a light load. There are several different ways to provide oil to rolling contact bearings, including forced circulation, constant level oilers, oil baths, splash feed methods, and drip feed methods. A forced circulation system is a common method for lubricating rolling contact bearings with oil. In this system, a pump supplies a steady supply of oil to the bearing. The pump sits on top of a rectangular reservoir called a sump. After leaving the bearing, the oil collects in a reservoir so that it can be pumped again. Oil filters in the system remove dirt and contaminants from the circulating oil. Coolers are also used to remove heat that the oil picks up from the bearing. Another way to lubricate bearings is with grease. Grease is generally used to lubricate bearings that are installed in machines that operate at slow speeds under heavy load, such as large circulating pumps. When adding grease to a bearing, it's important to use a grease that is compatible with the grease that is already in the bearing. Mechanics generally use one of three basic methods for greasing a bearing. They can grease the bearing with a grease gun, pack the bearing by hand, or use a grease cup. These methods are used only with bearings that are not sealed. Sealed bearings are permanently lubricated and they do not have to be greased. Many bearings that have to be greased are contained in housings that have grease fittings. A grease fitting is a small rounded projection on the housing that has a hole in it. To grease the bearing, a grease gun with a matching fitting is attached to the fitting on the housing. When this method is used, it is often necessary to remove the housing drain plug to allow old grease or excess grease to drain out as new grease is pumped in. Grease should be applied to the bearing while it is in motion to ensure that the grease will be evenly distributed. If the housing doesn't have a drain plug, the excess grease or old grease leaves the bearing through the shaft seals. In this case, it is very important to add grease slowly to the housing so that the shaft seals are not damaged. A good rule of thumb is to pump the grease gun no more than 2 or 3 times unless specific plant guidelines state otherwise. When you're installing a bearing, you may have to hand pack the bearing with grease. To do this, hold the bearing in your hand while you press grease in between the rolling elements. Make sure that the grease is distributed evenly throughout the bearing. Pack the bearing 1/3 to 1/2 full of grease. If too much grease is added, rotate the bearing slowly to force out the excess grease. Another way to lubricate a bearing with grease is to use a grease cup. A grease cup is a threaded container with grease in it that is mounted on the bearing housing. The top of the cup is turned to force the grease into the bearing. In this topic, we looked at the functions and features of rolling contact bearings and at some common types of rolling contact bearings. We also looked at different mountings and housings for bearings and saw how bearings can be lubricated. Now try some practice questions. Rolling contact bearings can last for years, but eventually all bearings fail. There are several factors that can cause bearings to fail and several specific types of bearing failures. Usually, it's possible to tell a bearing is failing before removing the bearing from the machine. Bearing failures are often accompanied by high levels of noise or vibration, high operating temperatures, and the smell of burnt oil. After a failed bearing has been removed and taken apart, other evidence of bearing failure may be seen. This evidence may include burn marks, which are blue or brown marks on the rolling elements or the rings, spalled areas, which are places where the surface of the metal has flaked away, a bent or broken retainer, cracks in the rings, and discolored lubricant. If the bearing failure is unusually severe, all of these signs could be present, but not all of the signs are necessarily present with each type of failure. Let's look at some common types of rolling contact bearing failures. One type of bearing failure is fatigue failure. Fatigue failure happens to every bearing eventually. It occurs because the bearing has worn out. Symptoms of fatigue failure may include loud noise and vibration, high operating temperature, burn marks, spalled areas, a bent or broken retainer, or cracks in the bearing metal. Fatigue failure is caused by metal fatigue. When a bearing is in operation, it is continually flexing or bending. Although the amount that a bearing bends is very small, it is significant because it is continuous. There is a limit to the amount of bending and flexing the bearing metal can tolerate. After the metal has reached its limit, the bearing fails. Another type of bearing failure is lubrication failure. Lubrication failure occurs when the oil or grease in a bearing fails to function correctly and the bearing overheats. Symptoms of lubrication failure include the smell of burnt oil, discolored lubricant, and burn marks on the rings or rolling elements. Lubrication failure can also be caused by improper lubrication. This could mean too much or too little lubricant, using the wrong kind of lubricant, mixing lubricants that aren't compatible, or using contaminated lubricant. Misalignment failure is a type of failure that occurs when one ring of a bearing is out of line with the other. The primary sign of misalignment failure is unusual wear marks on the inside of the rings. A normal wear pattern follows the center of the ring. Thrust failure occurs when there is more axial load on a bearing than the bearing can handle. The signs of thrust failure include cracked rings, a bent or broken retainer, and loose rolling elements. Thrust failure can occur for a number of reasons, including incorrect bearing selection, improper installation, and excessive installation force. Rolling contact bearings are usually installed with a press fit on one ring and a push fit on the other. Removing a bearing that has been installed with a push fit is relatively simple because it is a loose fit. Removing a bearing that has been installed on a shaft with a